So we're moving on to 9.3, which we're going to actually solve our quadratic equations. And we're going to kind of talk about what does it mean to solve a quadratic equation. We're going to start by graphing. So I want to do a review of graphing from 9.1 and 9.2. You can see that I've already written stuff down here. Go ahead and pause it if you need to write this down again. When we have a quadratic equation, we know that our general form is y equals ax squared plus bx plus c. Well, if we only have the ax squared, we know our vertex, make a table and graph. If we only have the ax squared and the c, same thing. We know our vertex, it's going to be 0, comma, whatever the c is, make a table and graph. And then 9.2, we learned there's a few more steps. When we have the entire quadratic, the a, the b, and the c, we have steps we have to go through. Okay, so we're still practicing our graphing, but we're going to add the piece on what does it mean to solve. Again, I know this is a lot to write down, so please pause the video, get it written down, and then unmute me. So what does solving mean? It means get an answer, right? It means get an answer. And so when we're going to solve here, these answers we call the roots of the equation, or we also call them the zeros of the function. So let's talk about what that means. What we're actually solving for is when y is 0. And so we're looking for our x-intercepts. When we look for the roots of the equation, or what we call the zeros of the function, we're looking for a number for x and when y is 0. And there's 3 different types of answers. Okay, we can either have an answer where we actually have where our parabola or our quadratic is crossing our x-axis at 2 spots. That would be 2 answers. This example, it looks like those numbers are -2, 0, and +1, 0. We also can have our parabola graphed where it only gives us 1 answer. That means that your vertex is actually on the x-axis. So you're actually going to have that vertex on the x-axis, and it's also your answer. This one would be 0, 0. 1 answer. And then we have our third type that we can get. A lot of different kinds of quadratic equations, but we're only going to end up with 3 different types of answers. One of these, either the 2 answers, the 1 answer, or the no real answer solution. The no real answer solution, here's my x-axis. Do you see it crossing it anywhere? No, it's not crossing anywhere. So this is a no real number solution. This is actually, when we get into Algebra 2, we'll talk about imaginary numbers. Okay, so this is all we're going to write for today would be no real number solution or answer. So let's go ahead. We're going to look at 2 examples. Nope, I'm sorry. We're going to look at, I think, maybe 1, maybe 2. We'll see here. Let's look at a couple examples, and we're just going to identify how many solutions we have by graphing. And when we solve it, what we are identifying is our x-intercepts. We are identifying what our x-intercepts are. We are also know that there are 3 different kinds of answers we can get. That's it. 2 examples. Here we go. So what I notice here is, what form do I have? I have ax squared, I'm going to put my 1 in for a, plus 7. So what does that mean? That means, let's go ahead and we know our vertex. My vertex here is going to be 0, 7. So let's make a table. I'm going to go ahead and put 0, 7, remember, for our vertex. This should be a review of graphing. right in the middle. What I also want you to realize is it doesn't say y equals x squared plus 7 anymore. Because remember, when we're looking for our zeros, we want y, when we're looking for those zeros, we're finding a number for x, and we want y to be 0. So we want to make sure that we are setting it equal to 0 first. Now let's think, what is 1 less than y? I'm sorry, not y. What is 1 less than 0 on my vertex would be -1. 1 greater would be +1. Let's go ahead and substitute that in and see what we get. If I put 1 in for x, I square it, plus 7, still equals 0. That's okay, we're just getting an answer here. 1 squared is 1, plus 7 is 8, so both of these would be 8. And then let's go one more spot to see what happens. 2 and -2, so if I put 2 squared in, I get 4 plus 7, which would be 11. So let's visualize this graph. Let's see if you can help me visualize it here. Here's my x-axis and my y-axis. Let's start to plot these points and see what you see. If I'm at 0 up 7, let's count by 2s. 2, 4, 6. 0 up 7. Trying to count by 2s, sorry. There we go. And then we're going to go over to -1. And we're going to go up to 8. And +1 and 8. And then we're going to go over to -2 and up 11. Talk to me about, is this quadratic? Hopefully you can visualize it. Is this parabola, this quadratic, ever going to cross the x-axis? No, it is not. So this would be an example of no real number solutions. No real number solutions. And we can see it by graphing it. Let's look at our last one here. Our last example, we are still in the form of ax squared. I'm going to go ahead and change this plus c, which would be a -12. So we know that our vertex is going to be 0, -12. Let's go 1 less, we'd be at -1, 1 greater, we'd be at +1. I'm going to go ahead and substitute +1 in. So if I had 3, +1 squared plus -12, 1 squared is 1, times 3 plus -12, 3 plus -12 is going to be -9. Remember, since we're 1 away, since our x values are the same distance away from the vertex, that means our y values have to be the same distance away. Let's go ahead and look at putting in one more value. Let's put in 2. So on this one, 2 squared would be 4. Two times 2 is 4. 3 times 4 is 12. Ooh, what do you notice here? 12 and -12 actually gets me 0. When we find the 0 for the y, what does that tell us? Those are my roots. You have solved this. That is where they're going to cross the x-axis. Now let's visualize this graph. Let's just visualize this graph. I'm going to sketch it to the best of my ability. We start at 0, -12, all the way down here. Let's count by 3s, I guess. And we are going to cross the x-axis at -2, 0 and +2, 0. So how many solutions do we have? This is a 2 solution. 2 solution. So hopefully what you took away from this is we're still looking at quadratics. We can solve our quadratics by actually still graphing like we did in 9.1 and 9.